Magnetic field. Magnet. A magnet is a material or object that produces a magnetic field. This magnetic field is invisible but is responsible for the most notable property of a magnet, a force that pulls on other ferromagnetic materials such as iron and attracts or repels other magnets. A single magnet pole has never been isolated. Magnetic poles are always found in pairs. Magnetic field. A magnetic field is a vector field that describes the magnetic influence of electric charges in relative motion and magnetized materials. A charge that is moving parallel to a current of other charges experiences a force perpendicular to its own velocity. Electricity and magnetism. Electric current can be produced in a circuit either by moving a magnet near the circuit or by changing the current in a nearby circuit. Changing magnetic field creates an electric field, and the reverse is also true. We can define a magnetic field B at some point in space in terms of the magnetic force F sub B that the field exerts on the test object, for which we use a charged particle moving with velocity v. The magnitude Fb is proportional to charge q and the speed v of particle. When charged particle moves parallel to the magnetic field vector, the magnetic force acting on the particle is zero. When the particle velocity vector makes an angle theta which is not equal to zero with the magnetic field, the magnetic force acts in a direction perpendicular to both v and b. The magnetic force exerted on a positive charge is in the direction opposite the direction of the magnetic force exerted on a negative charge, moving in the same direction. The magnitude of the magnetic force exerted on the moving particle is proportional to sin theta, where theta is the angle the particle's velocity vector makes with the direction of b. So the vector Fb is equal to qv cross b, and the magnitude of F is equal to absolute value of q into Vb sin theta. The right-hand rule for determining the direction of the magnetic force Fb acting on a particle with charge q moving with velocity v in the magnetic field B. The direction of v cross b is the direction in which the thumb points. If q is positive, Fb is upward. If q is negative, Fb is downward, anti-parallel to the direction in which the thumb points. There are several important differences between electric and magnetic forces. The electric force acts in the direction of the electric field, whereas the magnetic force acts perpendicular to the magnetic field. The electric force acts on the charged particle regardless of whether the particle is moving, whereas the magnetic force acts on a charged particle only when the particle is in motion. The electric force does work in displacing a charged particle, whereas the magnetic force associated with a steady magnetic field does not work when a particle is displaced. When a charged particle moves with a velocity v through a magnetic field, the field can alter the direction of the velocity vector, but cannot change the speed or kinetic energy of the particle. We see that the SI unit of magnetic field is the Newton per Coulomb meter per second, which is called the Tesla. 1 Tesla is equal to Newton per Coulomb meter per second. Because a Coulomb per second is defined to be an ampere, we see that 1 Tesla equal to 1 Newton divided by ampere meter.